All right, we're going to go ahead and do the 3 examples that we did not get to for the stuff that we covered in Packet 8. So example 3. A set of middle school student heights are normally distributed with a mean of 150 centimeters and standard deviation of 20 centimeters. Darnell is a middle school student with a height of 161.4 centimeters. What proportion of student heights are lower than Darnell's height? Alright, so let's start off by circling the important parts. The mean is 150. The standard deviation sigma is 20. Darnell is 161, so that's our value. And then what proportion are lower? Alright, so I'm going to draw my normal curve because they told me that the heights were normally distributed. Alright, I name it 150, 20. Here's my mu of 150. Here are my standard deviations above and standard deviations below. Alright, so let's go ahead and calculate the z-score with its value. Z is equal to value minus the mean over the standard deviation. Should be a decimal point. Alright. Desmos 161.4 minus 150 divided by 20. And I get a z-score of 0.57. So does that make sense? Z-scores are typically between -3 and 3, so yeah, a z-score of 0.57 makes sense. If I were to interpret the z-score, I would say that Darnell's height is 0.57 standard deviations above the mean because it's positive. So if it's 0.57 standard deviations above, I'm going to guess right here in my drawing. So I'm going to say this is Darnell. This line right here. Alright, and we're trying to find what proportion are lower. So am I going to shade to the left of Darnell or the right of Darnell? I hope you said to the left of Darnell. So I've shaded to the left, and my last step is just to find the area of the curve to the left of the z-score. Now the z-score is not part of the empirical rule, so I need to use table A to look it up to find the area. So I'm going to go to table A. So right now I'm in your teams. I went to the general tab and I went to posts. I went to files. And then within that box, I clicked on class materials. And then I clicked on table A, and I know that I have to go to page 263. My table A up, and I have it zoomed in, and I'm looking for a z-score of positive 0.57. So I keep scrolling, looking for positive 0.57. Alright, here's 0.5, so I'm going to go over to the right until I get to 7, and I see that it's 0.7157. So I'm going to write P is equal to 0.7157. 0.7157. Alright, so I just went ahead and wrote P is equal to 0.7157. So that's the proportion of student heights that are lower than Darnell's. To write it as a percentage, it would be 71.57% of heights are lower than Darnell. Alright, so that was example 3. We went through the rest of these in class. I think example 5 and 6 were the 2 that we hadn't gotten to as well. Alright, so example 5. A set of chemistry exam scores are normally distributed with a mean of 70 and a standard deviation of 4. Cam got a 65. Alright, so I know 70 is my mean, 4 is my sigma, and Cam is my value, 65. Alright, what proportion of exam scores are higher than Cam's score? So let me go ahead and draw my normal curve. And yes, on the AP exam, you will need to draw the normal curve. So that's my mean, which I know is 70. I have to name it. Normal, 74. I've got my 3 standard deviations above and my 3 below. Alright, now I need to go ahead and calculate, and I can go ahead and fill in these values right here because this is easy for me to add in my head. I don't want to stress myself out too much. Alright, 70 plus 4 is 74, 78, 82. If I go backwards, 66, 62, and 58. Double checking just to make sure that is right, and I'm pretty confident. Okay, so now we calculate z-score. Value minus mean over standard deviation. Alright, value minus mean, oops, that should be a 70. And you know how I knew it should be 70? I had a z-score of 14.5, and I know that's not what a normal z-score is. A z-score is between -3 and 3 for the most part. Alright, there we go. 65 minus 70 divided by 4 gives me a -1.25, which sounds more like a z-score. So if I asked you to interpret the z-score, what would you say? I hope you would say that Cam's score of 65 is 1.25 standard deviations below the mean. So I know it's more than 1 standard deviation below, but not quite 2, right? So I would say that Cam is about right here. We'll say that's Cam, this line right here. Okay, so now we're looking for a proportion of scores that are higher than Cam's score. So should I shade to the left of Cam or to the right of Cam for the proportion that I'm looking for? Alright, I hope you said to the right because of the word higher. I'm looking for the proportion of scores that are higher. Alright, so if I'm looking for the proportion of scores that are higher, I do the same thing as I did when I shaded left, I just have one extra step. So let me go ahead and find the value of P for that z-score. Alright, this time I should be in the negative section. Negative 1.25. So here's negative 1.2, and I'm going to go over to the 0.5. So I have a P is equal to 0.156, which is the same thing as 10.56%, right? Alright, so when I go back, I know just by looking that I cannot be done, right? Look at how much of the curve I shaded, well over 50%. So I know that my correct answer cannot be 10.56. And I realize that the table A gives me everything to the left. So what I need to do is subtract it from 1. 1 minus 0.1056 is going to give me my area. So right now what that gave me was my unshaded area, 0.1056. And I know I can find the other side by subtracting that from 1. So 1 minus 0.100056. Whoa! Okay. That gives me 0.8944. So I know that this area right here is 0.8944. And they sum up to equal 1. Because we know it's a density curve, right? Remember, normal curves are density curves. The area underneath the curve is 1. And if you're curious about how we got the values in Table A, you can just ask your friends who are in AP Calculus. So actually you use calculus to determine the area under a curve. So we know that if the total area under this curve is 1, you use calculus to figure out at each point what area is to the left. But, lucky for us, we're not in AP Calculus, and we can just use the Table A to determine the area. Alright, so I ended up getting 0.8944, or I'll say 89.44% of exam scores are higher than Cam's. So does that mean you would be happy or sad if you were Cam? Alright. Alright, we've done enough of these. I want you to go ahead and try example 6 on your own. You can do it. Alright. A set of sofa prices are normally distributed. I must have been furniture shopping when I made this packet with these numbers. Alright, a set of sofa prices are normally distributed. No, I must not have been. This is definitely not what I'd be spending on furniture. Alright, this is the mean, and this is the standard deviation. And a leather sofa has a price, so we're looking exactly at the leather sofa, so that's our value. Alright, what proportion of sofa prices are higher than the price of the leather sofa? Oh my gosh. I draw my curve. I name it. I have my mu. Alright, I have my standard deviations. Alright, let's get the z-score. So z is equal to 2410 minus 2500 divided by 200. Value minus mean over standard deviation. Alright, I got a z-score of negative 0.45, and that makes sense because z-scores are between what two numbers typically? Alright, so if my z-score is negative 0.45, how would I write an interpretation of what this z-score means? Okay, I would say that the price of the leather sofa is 0.45 standard deviations below the mean. Alright, which would be maybe about right here. Alright, so here's my leather sofa, LS. Alright, and what direction am I shading? Am I going to shade to the left of that LS line or to the right? Alright, I would say to the right because of the word higher. Alright, there we go. Alright, now I'm going to go back to my z-score table to pull up the p that's associated with negative 0.45. Negative 0.4. Alright, there's the 0.4. 0.45. There we go. So 0.3264. Alright, looking back at this, remember that table A gives us everything to the left. So my unshaded part of the curve is 0.3264. So I'm going to do 1 minus 0.3264 to get my shaded part. Alright, and you should get 0.6736 or 67.36%. 67.36% of sofa priced higher than that leather sofa. Alright, now we'll go over part 3 next time we're in class.